G'day and welcome to MW Laser. My name's Matthew. In this video we're going to have a look at the mark point positioning calibration using RDWorks. Now mark point positioning is a very accurate way to cut out pre-printed designs such as UV printed acrylics, timbers, stickers, business cards or paper. So what we'll do is have a look at the installation of the software and importantly the camera calibration. Now if you don't already have the software, what you'll do is go to Ruida's website, which is www.rdacs.com, and put in a / there for the English version. After you've done that, you can then click on Downloads, go down to Control Software, scroll down, select RDWorks version 8, and there's also here the RDC Mark Vision USB. Now the installation of these files can be seen on a previous video on the camera calibration in RD Mark Vision, so you can follow the steps for installing RDWorks and RD Mark Vision. Now once you have the software installed, open RDWorks version 8, power on your machine, make sure that the camera is connected via USB to the PC and that your laser controller is connected via Ethernet or USB to the computer. Now in relation to installation, you can always follow a previous video I did on the RD CCD camera, which showed the calibration in RD Mark Vision. So this is the camera calibration for RDWorks. So you do need to do the calibration in each software. The calibration done on one piece of software does not automatically copy over to RDWorks or vice versa. Now once you have connected successfully, just double check that it is, so you can click on the device setting down the bottom, and if you're connected via Ethernet you can put your IP address in, or USB you can connect via USB by ticking the USB box, and to check you're connected successfully click on Modify and test that port or whatever device you're connected to, and it will come up and say Port Test Success and show the model number of your machine just in this little section here. So you're connected successfully. So then once you're connected, you'll see this mark point positioning box up here. So click on that and it will open up the camera view. Now what I'm going to do is just arrange this here so you can see the different things happening at the same time. So you can see I have printed out a reference piece of paper. Now the dots that I'm using as mark points are 6mm dots, and we're going to use that for the calibration. So first of all you need to adjust the brightness and the field of view of the camera. So what we're going to do is move it down over that white piece of paper just using the cursor keys on the control panel. You can also use the move button on RDWorks. So if we click on RDWorks Test, you can also use these buttons here to move your laser around. So what we're going to do is just select one of those dots. We'll go to one of the small dots because that's what we'll use for the calibration. And you can see that there. So we need to adjust the field of view, brightness, gain, all that sort of thing. Now if we zoom in now just on the camera itself, you'll see that it has various rings for focusing and field of view. So these 3 separate rings can be manually adjusted, and we'll compare that with the vision that we're seeing in the mark point positioning window. But the lower ring here is near and far, sometimes labelled NF. The middle ring is labelled open close, and that's often labelled OC. And the top one is wide and tele, and sometimes you'll see just W and T written on it. Now what they do, the wide and tele regulates the camera sharpness. The OC or open close, the middle one, is your aperture. So that will adjust and regulate the camera's brightness. And the near and far, which is the lower one, will regulate the focal length and the field of view of the camera. So we'll just show that now. So you can see that now when I make adjustments, you will see the adjustments made on the Mark Vision section beside it in the camera window. So I'm just going to loosen the middle one here, and this adjusts the camera aperture. So this is the brightness of the camera. Now the camera also has a ring light that you can turn on, but we can get it set without the ring light if necessary. So we adjust the camera brightness until we get a nice picture. We can also adjust the field of view so it can see larger sections. So just carefully adjust these, and you can see by bringing it in and out, we can get the dot into focus. Okay, so we set that and just tighten the screw again. It's just a little thumb screw or a small screwdriver. And then the top one is the wide and telly, so we can adjust the sharpness of that. So it's a little bit tight, and get it nice and clear. Now, if we use the scroll wheel on the mouse over the top of this camera reticle, we can also zoom in so we can see it a little bit clearer. So we adjust that until we're happy with the image, and then lock that into place. So once they're nicely into place, you want to have some good contrast there so it can detect your dots. And that's how you adjust the camera lens. You also have the camera light, which can be adjusted, and you can turn that on and adjust the brightness as necessary. So if you don't need the camera light, you can just leave it off. It's only used in very dark environments, so if you're not getting the results you want out of the camera, adjust the brightness using your camera lights. Now, just a little note about the camera. I will just turn this back on, and you'll see that there's a little selector switch on the top of the camera. If you slide that to the right, it will go to a red light, which may give you some adjustment that you can get better adjustment with your camera using that red light. Otherwise, it's just the white light. So you can see that red light. I can see in the camera window, it's a nice grey dot. And if I switch it to white, you can see it sort of blanches it out a little bit. So you can just adjust things like that until you get nice, crisp image. Okay, just a little bit about this camera view here that we have. We can scroll in and out using the scroll wheel on your mouse. And you can also move it using a right click in this camera reticle. So if we click on this side of the red line, you'll see that the laser moves in that direction, and we can just go around different points on this little cross until we get it close to the center. We can zoom out. You can also fine tune that, like I said, using the test tab over here. We can then use the Y up or Y down, and the speed that it travels is here. So if you really want it to go slow, you can put in 1 millimeter a second and just move it 1 millimeter a second. The difference is now this still says an offset of 1. So if we want to have just continuous movement rather than an offset, we can go continuous movement, and it will just move a little bit at a time. So you can adjust using these buttons. Now, once you've got it close to center, then that's ready to go to the next step. So click on the setting button and enter the CCD calibration. All right, when you open up the CCD camera parameters, you can see that you can see the camera, you can adjust the contrast, the gain. You can also have continuous auto exposure. So this will adjust if the lighting in the area that you're working in adjusts. You can leave continuous on, but you can also adjust your exposure and things like that here. You can also rotate the image. So if this that you're seeing was not clear or upside down, we could adjust it 180 degrees to make sure that the orientation is correct. So if it was set on 0, that's how it is in my machine, but I've adjusted it to 180 degrees. So again, we need to make sure that we have a clear image. Now, using the adjustments here, we can view the screen and adjust the focus, the brightness, the white balance, the auto exposure, that sort of thing, until you get a nice clear image so that the camera can pick up those mark points effectively. So now we have a nice clear dot that we're going to work with. Now this dot is 6 millimeters, so we're going to start the calibration. So that we type that down here, we type in 6 millimeters. We're not going to cut the circle because we've already got a circle printed, so the circle is going to be 6 millimeters. Now for this graph length, what we do is we drag in this green box using the mouse to the edges of our circle. So we know that this circle is 6 millimeters printed, so we move these green boxes right to the edge and we adjust it as close as possible to the center so that we get a nice measurement. Zooming out with the scroll wheel, we can then also adjust this down. Just drag that one down and we zoom in. So we want to make sure that the whole circle is encompassed by this green box and that no part of the circle is outside of it. Now you'll see on the side here that it will show that this is measuring at 10.53 millimeters. So we go down to the graph length and enter in 10.53. We calculate that and we do a match test. It will pop up with this box saying the circle diameter equals 5.773. So we record that and we type in here 5.773. We calculate it and then we do another match test. Now we can see that the circle diameter equals 6. So that's successfully calibrated the size. Now you just keep going through this procedure of entering in the graph length and the match test until you're as close to 6 as possible. It may be 6.001 or 002, that doesn't matter, get it as close as you can, and then that is the calibration of the size completed. The next step is calibrating the offset between the camera view and the laser head. So what we do here now is we move the laser head to a clear piece of material. I'm just going to cut over here on the pine or the timber, and you can see my field of view there. We can extend this field of view up and out again now. We can have it so that this is where the camera will detect. And now what we're going to do is set a cross size of say 30 millimeters and we will actually press cut cross. The laser will then cut the cross and the camera will go over the top of it. Now this could be quite a long way out, but the idea is that we get this reticle of the camera directly over the cross that is just being cut. So we zoom in, and again using the same steps with either using the right mouse click or by using the axis move buttons, we want to get as close as we can to the center of that cross. So we can zoom all the way in to get the highest accuracy. Now when I'm moving here, just a reminder, I'm using continuous movement with a speed of 1 just to keep things really slow so that I can adjust, fine tune it. If I want to fine tune it even more and say, well, a 1 millimeter or 1 millimeter a second is too much, or I want an offset of 0.1 of a millimeter, I could then turn the continuous movement off and I would move only 0.01 of a millimeter in each direction. So you can fine tune that and get it as close as you can to the center of that cross. Once you've done that, you press on the calibration and that will then pop up and say success. So as you saw last time, when we cut the cross, it didn't quite overlap properly, so we're going to redo that. So we move the laser again to a clear piece of material and we cut that cross again. And you can see now when we zoom in that it's gone directly over the top of that cross. So that is your calibration complete. If you need to fine tune, you can actually fine tune it even further and press calibration and then recheck. Now, it's a very good idea to export your calibration files so that if you do change computers or if you need to reload the software, you can just import the calibration file without the need to redo your calibration every time. So we're just going to call this MW Laser 1610 and then whatever date or time or whichever machine that it's attached to. Save that file. So next time if you were to load the calibration and the calibration was out, we could import that calibration file and we know that that is now correct. And you can check it after you've imported it, again by going to a clear piece of material, cutting the cross and seeing if it's over the top. We can also check the size calibration again, either by using a printout or we can actually tell it to do a circle cut. So we might cut a circle that is 30 millimeters. We will cut that circle. The camera will go over the top of it. We zoom out. We tell it that the circle is 30 millimeters and we do a match test. It will calculate it and say it's 29.118. So if you want to fine tune that any further, we can. Just remember that obviously the line is either on the inside or the outside. So some of these deviations in values could be the thickness of that line. That's why I like to use a printed copy. So if you wanted to do a match test on this little dot again, we could tell it that the size is 6 over here and do a match test and it will come up and say it's 6.025. So we know that our size is correct and our positioning is correct. Okay, so now we're just going to do a test. So what I've done is I've printed out an A4 piece of paper with some shapes and some mark points. You can see that there. So now what we can do is using the File Import button, just go to File and Import, and you will open up the corresponding cut file. I've saved this one as an Adobe Illustrator file. They're supported files. There are a lot of different supported files that it will use for your mark point positioning. I generally use AI or DXF. So we import that file. You will see that it pops up all selected and everything is red, which doesn't correspond with our cuts and layers over here in our work tab. So we click off it, you'll see that they go black and we have our targets as blue. Double click on your target ones or your mark points and say output no, unless you really want to cut those mark points out. But then we can select the black layer, which is our cutting layer, select our power and our speed, whether we're cutting, engraving, whether you want air on, all the normal things that you use with RDWorks. Now, because we're not outputting the blue layer, it will stay there as no. So there's no other layers on there, so we don't need to adjust which order they do things in. But if you wanted to adjust these, you can just drag them down into different orders. So if you had multiple layers where you had some engraving that need to be done using the mark point system, you want to make sure that they're engraving first and then cutting last, so you can still do the same features that you use with RDWorks. Now we're going to open up our mark point positioning tab. Just drag them out of the way because they do seem to topple on top of each other as you open them up. But we need to get close to this mark point that we're going to use as our starting point. So you can see in the machine, I've positioned the camera over the top right-hand corner. So this dot is the top right-hand one, so you can drag around here and select that mark point. Now we're going to go Set Mark and select that mark point again and press Set Start Point. So that's our starting point and we're now ready to cut. So there's some other things I want to show you here, and that is that you can move these mark points around and you might want to move one up or down. You can move them up and down here. Emptying will delete all your mark points and you'll need to start again. Even going back as far as importing your file, but you can add other mark points or take ones away that may not actually be mark points. So it might be a small circle that needs to print and the software is detected as a mark point. So you want to check for those and delete them if necessary. The other thing that we want to do is have a look at the other setting, and this will give us an option to move back to our homing point or no return, so when it's finished cutting it just finishes where it was, or you can ask it to go back to the mark start point. So we can actually move all this around. I'm just going to leave it at homing point and say OK. Now we're ready to cut, and I'll change the screen so you can actually see it in big view, and we'll press start on this button. Now it will go around and detect all those 4 mark points. Once it's finished, it will start cutting. So there you have it. They're the basics on how to calibrate your camera with your RDWorks software for mark point positioning. Thanks for watching. Until next time, take care. Cheers.